All right, everyone. Thank you for joining me and everyone else here in our official The Graph Discord for Graph Builders Office Hours number 15. We are going to be starting with a presentation that I'm going to give on file data sources. And then we're going to be following up with Derek, who's going to be giving a presentation on GraphNode updates, specifically 0.33.0. So if anyone has any questions at any time, just go ahead and throw them in the chat, and we'll be keeping tabs on that. And without further ado, let's get going into the workshop. So this is the presentation, File Data Sources, bringing off-chain data to subgraphs with Arweave and IPFS. This might be familiar for some builders who are here in the past. Builders Office Hours number 5. Presentation file data sources with just IPFS. This is going to be file data sources with IPFS and Arweave. So if you want to get a little bit of information specific to IPFS, go ahead and go back there, and then also go into a little bit of JSON data handling within the subgraph. So that's something that might be a little bit more interesting to you. This is just going to be using IPFS and Arweave in the same subgraph. So for that previous repo, if interested, this is that repo right there if anyone wants to scan. And you're able to go through and learn about file data sources and IPFS. This one today is going to be a file data sources repo that does Arweave and IPFS, like I said. This is an official repo from the Graph tooling, and it can be found in this location right here. This is the Matic Lens Protocol Post subgraph. This subgraph indexes Lens protocol data, and we're going to be getting data from Polygon that's on-chain, and the off-chain data we're getting is Arweave and IPFS. So go ahead and check out Graph Protocol / Graph Tooling, examples, Matic Lens Protocol Post subgraph. We're going to dive into that well, not right now, but in just a second. So let's see. Any questions so far? No questions? Let's keep going. So the objectives today, we're just going to overview file data sources. We're going to see how it works specifically with a code along as well, just to get an idea of how to get it going. We're not going to go do deep dive into file data sources and how to build an incredibly robust subgraph. It's really just to show you how to trigger file data sources, how to get file data sources to start indexing your off-chain data as well as on-chain data at the same time in parallel, which is pretty cool. So here we go, file data sources. So really quickly, for those of you who are just beginning into your blockchain journey, I want to just show this image real quick of what the graph is doing, as well as what it's doing with blockchains, as well as now what it's doing with off-chain information. Our front end right here is what our screens are seeing all the time. And how do we get data from the chain? Well, in the graph, we have decentralized indexers around the world organizing the data for us and doing it and pumping that data into our front end, which is great. They're getting that data from the blockchain and finding specific data points, and they are given those instructions by the way of subgraphs, and that tells the indexers what to index. But now with off-chain data, it's not just the blockchain, we're also getting it from off-chain locations. So really, you're looking at subgraphs having many, many data sources, and really they become a single portal for various types of data that are coming in from all over the world, which is really, really cool. So how might we build a subgraph with file data sources? There's a few things that every person should do before deciding to build a subgraph with file data sources. Don't just go out there and build a subgraph with file data sources. You need to know a little bit of the architecture first. The first thing that is best to know is that there needs to be an on-chain event emitted from a smart contract that contains a ID that can trigger file data sources indexing. So just don't go out in there and build a file data sources subgraph. You just need to know a smart contract well enough that it has an event that you can extract an ID. And we'll talk about what a valid ID is in just a second to trigger file data sources indexing. But that's really important because if you don't have that ID, you're not going to be able to trigger the indexing of file data sources. So once you get that off-chain ID, you're then able to then find that off-chain metadata, whatever that might be. In this case, it's going to be a post content in the Lens protocol social network system. It's going to be able to find that post content that these users are making, which is pretty cool. And then once you have that on-chain event and then you're aware of the off-chain metadata, you could even build out a little bit of data handling with that JSON object if you would like, and that's in the previous Builders Office Hours number 5, where I go into that a little bit. And then finally, you should build your subgraph there. So just make sure that you have that on-chain event. That's really, really important. And this is a little cheat sheet that I made for anyone. This is a cheat sheet, kind of exactly how the data handling goes over. I'm not going to go in detail on this just because I'm going to walk through. But if you're ever curious, what should be happening in subgraph.yaml or in the mappings or in the schema, this is a quick cheat sheet just to jump into. So let's go into the file data sources information. No questions so far? Awesome. So the subgraph, like I said, that we are going to be building is this subgraph right here. And we're going to start in the subgraph.yaml. I've already spun up a subgraph that targets the Lens Hub protocol proxy smart contract. And I found that smart contract simply by just going to the deployed contract addresses. This is also Lens V1, just so you know. I know Lens V2 just came out literally a few days ago. But once again, this is just to show how file data sources works. So we're just going to go through that. This is a proxy and implementation pattern right here. This subgraph pointed to right here, and I just spun it up. That's all we have so far. And then we're going to go ahead and build this out a little bit. So right now, this is your smart contract that we're looking at, and we're looking at a few event handlers and entities. The entities that we're most concerned with on-chain is a post content entity, and that is going to be emitted every single time a post and its post is made. Excuse me, not post content. Excuse me, that is post created. Every single time a post is created, we go ahead and emit this event from the smart contract, and that's going to contain the ID that we definitely need. So the event handler that comes in that we want to actually create, once that data comes in, is going to be the post created event handler, and that's going to handle that data just fine. So next from there, that's pretty much done from that location. From there, what we're going to do is need to create the templates. So what are templates? Templates are what a subgraph will go ahead and use to trigger its file data sources indexing. And with a template, we're going to have two different types. We're going to have an Arweave and an IPFS template because we have two different types of, two different data sources that are coming in. We have this one here, and this will trigger through file data sources triggering in our contract.ts. We'll build that in just a little bit. But as you can see here, this is going to be populating the post content entity, or before we had a post created. It is important to know that when building file data sources, we separate on-chain information and off-chain information, especially in the subgraph.yaml. We're not able to actually populate on-chain information, off-chain information into an on-chain entity. We can do linking. That's just fine if we want to do in our schema, but it's good to have that separation. The subgraph won't actually function if they do go into the same entity. So the subgraph is smart enough to know that. The next one that we want to do is IPFS. And it's going to go through here. And it looks something like that. So it's the exact same thing. If you just notice, we have the name, the Arweave content, and the IPFS content. I'll get the tabs right. And those are the two different templates that will spin up when they are called with the create method, which we'll see very soon in the contract.ts handlers. So that's pretty much it. We've got our on-chain information that's going to be populating the post-created entity. And then we've got the event handler that's going to be handling that data. And then here we've got the Arweave data that's coming in, and it's going to have its own entity shared by also the IPFS template. And that is also going to be handled by the handle post content and handle post content right here, where both of these handlers are going to be the same. The post content that's coming in from Arweave is also going to be the handle post content that's coming in from IPFS. Okay. If there's any questions, let's see. No questions. Let's keep on cruising right through. Go ahead and drop the questions in the chat there, guys, if you have anything that you are wondering. So let's go ahead and build out our schema. Now, this is the schema that was created by the spinning up of our Graph CLI, which is fine. We defined two different entities that we needed. And so we'll just delete that right there. And we'll put our two different entities in right now. Let's start with the post created entity. And this is the on-chain log that's gathering our content URI. Remember I said if you have an on-chain event that's being emitted that has a valid ID, we need that valid ID to trigger file data sources indexing, to trigger those templates, okay? So this is the one that we have right there. If you're building your own smart contract, just make sure that when you pin that data on Arweave or IPFS that you get that actual information in here so that then you can trigger your templating. Next, we're going to have the content coming in. Very simple schema, just two things we need, just a demo. This is actually going to have the off-chain data. Once again, we have data separation. We have on-chain information and off-chain information. This will have the hash, which will be the ID that we are getting from this content URI. We'll be extracting it, and the content will be just that, the actual off-chain data that's being stored on Arweave and IPFS. So very simple with that. And as this is a log, we're just going to leave it immutable as true. We're not going to be expecting to change anything. Before I go on, no questions, let's keep going. So the next one and the final one, the most amount of work that we're going to have to do is in the contract.ts. This was spun up just by the default, by the CLI. I'm going to go ahead and delete the entirety of all of this. And we're just going to build it from scratch right now. So we're going to import a few different things right now from the helper library from GraphTS. And we're going to have bytes, data source context, and data source template. Typically, we're going to need data source context, and data source template for any file data sources that we're going to be using. You'll see that used in a little bit, and bytes we'll use for conversion in just a little bit. We'll also import the information from our template as well as our schema. And right now we're having a type issue, which is just fine. Let's go cd office hours. That's graph codegen. Graph codegen does a very good job with type safety. And oh, my spacing is off. That's bad indentation. That's why. Let's see what we have here. I believe this is also supposed to be contract. Quick debugging live. Contract. And this is also contract. I believe this is it. And if we don't debug this live, that is okay. We'll just keep on going because it does work just fine. Handle post content and the post created. That is on line 23. Okay. Well, let's just ignore for the sake of this demonstration. I will. I would like to debug it, but right now my hands are getting a little bit nervous. We're just going to keep on going on right now. Graph codegen, should you see any of those have issues right there, just go ahead and we'll solve those type safety issues. Let's just keep on going right through. So the first thing that we want to do is this ID. Now, whenever we are going to be using data source context and passing really context around, you can see this right here. The data source context helper will allow us to pass data from handler to handler to handler, and that's very useful. Let's say when we're getting information in the on-chain handler and we want to pass it to the off-chain. Remember, we have to keep data separation. Well, the context allows us to pass that around. And when we want to pass bytes, it actually passes a key value pair. So we're going to create a key right here that we'll use in just a little bit. Let's go ahead and just look at the on-chain data, the handle post-created data, and then we're going to create a very simple ID here that is just the standard. There's a little concatenation right there, and then we have the profile ID and the pub ID, and then we're just concatenating it for the ID, and then we have that new entity. We're just going to store that on-chain information very simply here, and we're done with actually gathering our content URI. That's going to have our ID that we need. Okay. Next, what we're going to do is something a little bit. It's not fully flushed out. Just for the sake of this tutorial, we're just going to simply find on this URI if there is an index of arweave.net or IPFS. That's all we're going to do. Now, in this URI, there might be other different off-chain data sources coming through. We're only going to be looking at Arweave and IPFS because that's all we're really interested in. And there might also be different strings and different ways that Arweave and IPFS use in its URI. That's fine because we're just using this for a demonstration. Let's just keep on going. We just need to get that index of that information. And then from there, we want to actually just see, okay, if that index does not even exist, we're just going to return. We'll just exit this. We know in that event, the handle post created, we're not having anything from Arweave or IPFS. However, if we do have some information that we are interested in, we're going to actually create to pass around. We want to actually create that context to pass around into different handlers to, let's say, have the same IDs of different entities, to actually have some more interesting data handling, this context is a very powerful tool that now with a new feature, also with 0.33, there's also context passing in even the subgraph.yaml, which is pretty dang cool too. So that's just a little side note. So the context, we set the bytes. We could set strings, set Boolean. There's many other things we could do, but we're just going to set this key value pair, and then we're going to pass in the entity's ID as a whole, and that ID is right up here. So we have that same context being passed around. So that's going to allow us to link anything else if we should choose, and we will actually, if we would like to spin this up even further and build it out a little further. Now that we have the Arweave index and also the IPFS index, it's continued on. Once I'm doing a little check right there, if Arweave index, there it is, if it exists, we're going to extract the hash. And we're going to extract the hash very literally. It's very, very strict in terms of the plus 12. We're just going to look if it's plus 12 passed. We're going to pull out that data point from plus 12 into that index, and then we're going to get that actual hash. And that's really the hash we're trying to extract. And then we are also, once we have the hash and we have the context, we then trigger data source templating, which is going to create with context. We have the Arweave content right there, and we are now triggering that templating that we have created in subgraph.yaml. So that is the Arweave content that we are triggering in the contract right there. And then if we do find an IPFS index with the IPFS content right there, we're looking at that string. We're passing in the hash to trigger the indexing, as well as the context, which is the ID. So really cool stuff. We got that going. Finally, once we have that triggered, it's going to want to know how to handle that information. So we'll go and move on to the handling of the post content. So here, really quickly, we're passing in the content. As you look before here, we're getting event data. Now we're actually getting the off-chain data, and we're bringing in as bytes right there. We have our hash, and our hash is we're able to gather that hash from the data source that was triggered by a data source template. At any time a data source template is created, we could pass and create with context, or just create. If we don't want to pass create with context, it can be just data source template.create, and then just pass in that information. That is just fine if we don't want to pass context. From here, anytime a data source has been instantiated, a data source template has been instantiated, we can gather the hash by just doing data source dot string param. And context, we can get the context. Go ahead and check the docs for more information about data source handling. There's a few other things that we can do. We can get the address, other things very interesting. Finally, we're going to get the ID. This is the ID that we've been looking for. We've passed through. We get the context from the data source. We get the bytes. We pass in the key to get the value, and we save the value right there as the ID. And then finally, we have our post. We are getting our new post content. We're passing in the ID, and then we have the hash content. We save it right there. So essentially, that's what we have with our file data sources walkthrough of how to build the file data sources. Hopefully that makes sense. What I'd like to do is just go to the Explorer and show right now we have the subgraph right now that's published live. This is live on the Graph network, and we're having the on-chain data, the post createds coming through, as well as the off-chain data. And then here we have the hash coming in, and also here's the post right there, and we are able to get that data live. So this subgraph, if anyone would like to build it and tinker around with it, is right here, like I said before. And the last thing I want to do is go through exactly what a valid ID is. I did make a note what a valid ID is. This is also in the documentation. This is just a copy paste here. For IPFS, it's a CID with just the CID and or with the actual file name. That works. And for Arweave, the transaction ID or the bundler ID works just fine as well. So that is everything for this workshop today. Let me see. Sample content, URIs, IPFS. There we go. Yes, thank you, Derek, Data Nexus. Derek brought up some sample content URIs that can be passed in to trigger the file data sources right there. And I'll leave that in the comments of the YouTube video once this is shared. So we have that right there. So If there's any questions right now, I'll be happy to answer them. And I do not see any questions right now. But I'm very excited about file data sources personally. I think it's really, really cool that a subgraph can be a portal that can bring in on-chain, off-chain data and can really provide applications, decentralized applications, a much easier developer experience. And being able to link those right within the subgraph and handle that data really quickly is something that I think is super, super cool. So without any questions, unless anyone has any questions, Derek, are you ready to move on to GraphNode 0.33.0 updates?
You know it.
Awesome. Okay.
So in GraphNode 33, this is when Arweave file data sources were released. And so this was 2 weeks ago. So that's a kind of a newer thing over to the mainnet, but it's now officially supported. And we just saw Marcus run a query against the decentralized network, and indexers responded, and all happy days. One thing that personally I'm really excited about this is the mix of on-chain and off-chain data just really aligns with our future goal of being able to index the world's data, right? And Polly, your mic is unmuted as a quick note. But yeah, it's really exciting, especially as we're moving forward towards a world of data services. All these different components that can be built together. It's going to be excited. I'm excited to see what people build with it. So I'll kind of skip over this one just because we had a nice presentation on that already. And thank you again, Marcus, for that. So we'll go into some of the things that builders should be aware of. I touched on this a few builders office hours ago before this was launched, but now it's live. We can use it, and it's fun stuff. So one of the first things is there's a big performance boost to substream powered subgraphs. If I'm not mistaken, this has to do with bulk inserts and being able to write a lot of data to the database at once. And so we'll see syncing performance increase or further increase with substreams, which is rad. There's not a whole lot to show on that other than just me telling you, hey guys, it's better. But these next ones are more what we can start tinkering with and things that we can have fun with. We now have a polling block handler. And so for some context, let me go to that page. For context, this has been something that has been requested for a long while, right? Back in 2019, that's when conversations first got started. But right now, or I should say prior to GraphNode 33, every time that you implemented a block handler, what that would do is it would stop at every block, and at the end of the block, it would run whatever logic you set inside your handler. So this handle fun shutdown, at the end of each block, it would then go into there and run that logic. But maybe you don't necessarily need it to run every single block. You just don't have an on-chain event or a specific function call that triggers in order for you to kind of piggyback that. So you are stuck with saying like, okay, great, I guess I'm just going to run this every block. And then you might have gotten kind of smart and said, okay, I'm going to run it every block, but the very first step of logic is going to be some type of a modulus to say, hey, every 100 blocks or every 1,000 blocks or whatever the interval that you actually require. And that's essentially what we've been doing with some of the subgraphs we built at Data Nexus is, first step is check and see, okay, do I really need to run it at this block? And if not, then good, you can stop there. But you still have to stop and run that logic between each block. And one of the reasons why that's important is it messes with your ability to scan block ranges. So if we look at how a subgraph is indexing, right? This is all, keep in mind, this is all linear, right? Subgraphs index blocks chronologically. So you start at the earliest block or whatever you stated as your start block in the subgraph manifest, and then it works its way to the chain head. So this one's currently indexing Arbitrum 1. This is just a sample recently deployed subgraph that I pulled off of the hosted service. But we can see, and I don't think that these guys have block handlers inside of their subgraph, but we can see that it's scanning block ranges, right? Scanning 2,000 at a time. And that's going to sync way, way, way faster than having to stop at each block, run the handler logic, see if anything was even needed to be run, decide that nothing was needed, so go to the next block, and then, do that 2,000 times. It's easier to just scan a range, which is why we've seen that block handlers really degrade your syncing performance whenever they're whenever they're included. Even if you put some type of an interval in there or some type of a modulus to say like, hey, run this every 100,000 blocks. Doesn't matter. You still have to stop at each block, run that, itty bit of logic, decide that nothing else was needed, and then continue to the next block. So scanning ranges is a beautiful thing for being able to sync things quickly. So let's take a look at how we actually implement this. I don't think that it's on this screen. I'll just pull up one of the subgraphs that we got to utilize it for. Inside your block handler, right? You have your typically you'll have your event handlers, right? Event handler. Here's the event. Go run this thing. It's inside this file, right? All that good stuff. However, with this one, we have our handle block updates, and that's stored inside a block handler. You now have this thing where you can say a filter, and in this filter, you can say the kind of filter should be polling, meaning it should only run every X amount of blocks. And here you can put in whatever interval you want. So if you want it to run every 10 blocks, you just put 10. If you want it to be every 10,000 or 100,000, what is that, a million? Every million blocks, you can put that in. But that'll help improve your overall sync speed of your subgraph if you ever need a block handler. Really common places where I've seen block handlers are in subgraphs where they're not the source of truth on pricing. Like this subgraph, for example, is for a lending protocol. And in that lending protocol, they don't determine what the price is. Whereas with the decentralized exchange, when a swap occurs, that changes the price of something. So now you have an event that you can link into, the swap event, and calculate what is the price now. A lending protocol doesn't have swap events, and so they're not the source of truth. And instead, you have to go ask and figure out, okay, what is my token price now? Which becomes really relevant when you're doing things like trying to show potential liquidations on your front end, or show an accurate TVL. Right? Oftentimes, people are stuck with only updating TVL in a specific pool or in a specific market, based off of the last time that market was interacted with. So we'll update the token price of the tokens in XYZ pool. We'll just use Ether and USDC. Let's say that that's a lending pool. And someone goes and they borrow from that. You can say, great, update the price now. But if no one interacts with that pool for 6 hours, then you're just kind of showing a stale price. So in this case, we use a block handler to get accurate token prices for TVL and liquidation metrics, or being able to see potential liquidations. And we just do that every 1,000 blocks on Arbitrum 1, right? Which ends up being like 5 minutes because their block speeds are super quick. So that's an example of how you can use block handlers, and all in all, it'll help you sync a lot faster, and it's a lot nicer rather than inside the code base itself. You don't have to write all of this if block number, modulus, number of blocks to check, blah blah blah. You can just instead know that the manifest is doing the lifting for you. So that's a block handler. Now, separately, you also have another filter called an initialization handler. And sometimes when you first load a subgraph, you want to be able to hydrate your store. And let's give a really prime example of this. If you're in any type of a decentralized exchange, or something where you want to store a token of Ether, right? Ether is not, that's not an ERC20. Wrapped Ether is in ERC20, but maybe you want to have like token information for Ether. But there isn't going to be, an on-chain event of deploying Ether because it was deployed when the blockchain was deployed. So maybe you just want to insert that into your database. Just do it once. We don't need to recheck it and see if we need to do it later. We just do it as soon as it starts and it's good to go, right? Or maybe you want to put in certain contract information about your factory or this, that, and the other thing. In that case, you can use an initialization handler, right? Instead of stating polling in the filter, you just say once. And as soon as that data source is initialized or instantiated, it will run that handler, and then it no longer needs to rerun that handler on subsequent blocks. So let's say that your protocol has a factory, right? Let me just pull up an example. We'll look at some Uniswap stuff. Good. So inside Uniswap, they obviously have their pool factory, and whenever a new pool is created, that gets emitted by the factory. So they have a handler called handle pool created. They're going to go and try to load their factory. If we look at what that looks like, it's going to attempt to get factory. If it doesn't pull it from the database, it's going to create it and then later save it. So then the factory gets created on the first time that a handle pool gets created. Instead, since you already know all the values ahead of time for this for this entity, you could just add an initialization handler and say, okay, great. When this gets created, create the factory entity, and that way we don't need to pre-check if it exists every time we run get factory. So you're going to get just slight optimizations in certain points, but the primary benefit is you're going to have access to data that you know ahead of time, and instead you're just adding some of these massive constant files where you're like, hey, here's a bunch of tokens that we know and they're kind of buggy, and so we're just going to push them anyways. This could all be handled by an initialization handler. So those are those 2 points. Let's go back to our change logs. So very, very excited for these 2 points. The other ones, data source context, I'm not going to dig into that too much because Marcus did a great job at kind of explaining what that is. It's very, very useful when you're, especially with anything having to do with templating and you want to pass data along to what your template should know. So whenever you're adding new data sources, being able to kind of piggyback certain data points that you want to store in that data source is very nice. Okay, good. Other than that, we have things that developers may not totally see, but things inside GraphNode that are just going to improve overall performance, fix a couple of bugs, help some indexers with some GraphMan commands. Always love those. So that's largely what I wanted to go over. Strongly suggest utilizing initialization handlers, and if you are using a block handler, set it to polling, because chances are you don't need to run logic every block. You probably only need to run it every X amount of blocks and figure out what X is for each specific use case. So there you go. That's what I got. If you guys have any questions, feel free to reach out to me or pop them in the chat, and I'll interrupt Marcus. But for now, I'm gonna pass the mic back to him.
Well, thank you much there, Derek, and for everyone who has joined us in this Graph Builders Office Hours number 15. We'll be around for another minute or two if there's any questions. And so thank you so much for joining us, and enjoy the rest of your day. All right, everyone, take care.